This video is about the volume of prisms, pyramids, and cylinders, and we'll cover cones too because they really are the same thing, basically as a pyramid with an infinite number of faces. So let's start talking about prisms first. And any prism, or any shape that's like a prism, as long as you have some shape, it could be, even this weird shape like this, and if it's acting like a prism, meaning that there are two bases that are parallel to each other and connected just straight along the pieces, and on the back side we have here connected to here. So you can imagine this shape is kind of a prism of sorts, or it could be a more traditional prism that is like this, a box, say, or it could be any shaped base. All we need to do is take the area of the base times the height of the prism, which is the distance between the bases. That's all we need to do to find the volume. So if we know the area of the base and the height of the prism, then that's the volume. No matter what shape the base is, that's always going to be the volume. And the reason is that really, if you can cut it up into small enough pieces, they basically all turn into little square-based prisms, no matter what the shape. And so we actually end up with a bunch of square-based prisms, which add up to make whatever weird shape that you'll have. You just have to cut them into small enough pieces. So if you remember, the area of the base times the height of the prism is the volume of the prism. Well, the same thing works if we are doing circles as our bases, and we call that, if you remember, we call that a cylinder. So if we have that, and it might be easier if I make this dotted for you like that. So I just need the area of the base, and that's just going to be this thing right here times the height. That's the distance between the bases, and that gives us the volume. So area of the base times the height equals the volume. And so we are going to write down a formula. V equals area of the base times the height. Now notice, when I did this, I made B as a capital B. That's because the base we're referring to this time is a two-dimensional base, unlike on a triangle, which has a one-dimensional base. So this is volume is equal to the base times the height. And no matter what the shape is, we have some weird shaped base, and we turn that into a prism by having second base that's exactly the same and connecting the pieces that correspond to each other. I'm just doing this quickly, but you can imagine we've got this prism type thing. It's just the area of that base times the height, which is the distance between the bases. So we have volume is equal to area of the base times the height. And that works whether it's a cube or a weird shape like this, or a rectangular prism, triangular prism, pentagonal prism, hexagonal prism, a cylinder, any of those things. area of the base, written with a capital B, times the height. That is the volume. Now, something that's really cool is if I have something that comes to a point, like a pyramid. So let's say I have a pyramid, and it comes to a point, let's just say right here. That pyramid's volume will always be the area of the base times the altitude, the actual height of it, not the slant height or the edge height, but the altitude area of the base times the height or the altitude is equal to the prism. And so for a pyramid, we're going to do 1/3 the volume. And it's an easy way to remember that is area of a triangle is 1/2 because we're in 2 dimensions, and we're in 3 dimensions, and so we're doing volume, and so volume is a 3-dimensional measurement. So we're going to take 1/3 of the volume. So V equals 1/3 area of the base times the height. And that's just like a prism, except we have 1/3 of it. Similar to a rectangle, you know, that 2D object that's a rectangle, the volume, or the area of a rectangle, 2 dimensions, is twice that of a triangle. So area of a triangle is 1/2 base times height. Area of a rectangle is just base times height. Volume of a prism is area of the base times the height, and the volume of a pyramid, or anything that comes to a point like that, is 1/3 base times height. So if we were to look at this shape, which is called a cone, it's kind of hard to draw a cone, but we'll draw a cone and see if, you know, people can kind of use their imagination that that's a cone. And so we've got this cone, and the volume of the cone is equal to 1/3 the area of the base times the height. And remember that capital B means area of the base. So volume is 1/3 the area of the base times the height. And it doesn't matter what shape it is. If it's got a flat base and it all comes up straight to a point, then volume is 1/3 base times height. And that height, remember, is the distance from the apex, this thing right here, I'm trying to draw an arrow to it, the distance from the apex to the base using a right angle. So this would come straight down and make a right angle down with the base, and that would be the height. So it's the altitude is what we commonly call it, but volume is 1/3 the base times the height. If it comes pointy, because you can think 3D, and so it's like a triangle, but triangle is 2D, so we do 1/2 for the triangles, 1/3 for the pyramids and things like that. That really is it for the volume of a prism, pyramid, cylinder, cone, any of those things.